The ds-incubator continues on the series about exploring data with the tidyverse. And today we are going to be talking about typical values, unusual values, and missing values. There is a section for each of those in the book that we are following today, and the objectives are to visualize the most common values in the data set and also the rare values, explore outliers, both analytically and also through plots. We will need to zoom into a plot to find those outliers. You'll see some strategies to do that. Also, we're going to be transforming incorrect values once we kind of decided that they are wrong with missing values as one strategy to manage that kind of issue. And lately, we're going to convert missing values into a logical value, either this is kind of wrong data, yes or no, like true or false, so that we can transform missing data into something we can work with, we can count and we can visualize. So those are the objectives of today. As usual, each series it has a dedicated repo. We've been working with this repo called ds.tidyEDA. And I'm going to scroll up all the way to the top of the repo to find the folders. Click here on the folder of the day, meetup number 4, for the contents of today's meetup. And in a way, it's also like a quick review of not just the conceptual aspect of what we are talking about here, but also a little bit of the tools. Remember, we are talking about exploratory data analysis with a very specific toolkit, which is the tidyverse. So when we do library tidyverse, we get a bunch of packages, including the one that we're going to be working with today, dplyr and ggplot2. Also, we've been working with a specific data set called diamonds that comes with the ggplot2 package. So when you attach ggplot2 by doing library tidyverse, or if you would, you can do also like library ggplot2. Then you get access to this data set. So you just type diamonds and you get a data set. But I wanted to highlight a couple of things that I think I forgot. So if you do question mark and the name of anything that exists in R, so for example, once you attach the package ggplot2, the diamonds dataset becomes available, and it does have a help file that you can consult to know more about that dataset. So if you do question mark diamonds, let me show you how you would do that in R. So let's go here to my console and just type there, question mark diamonds. So what you get is this HTML type of file here that you can explore, and it does have very nicely. It doesn't come by default, so actually the developers took care to define each of those variables. I think the useful ones for today are the variable called price, the one called carat, which is the weight of the diamond, and then the variables x, y, and z that correspond to the length, width, and depth in millimeters of diamonds. Also, remember that the dplyr package comes with a function called select that allows us to kind of zoom in a specific set of columns. In this case, we want to, for example, focus on those columns that I just defined at the top, just to kind of focus our attention on them. So if I do diamonds and then pipe that, remember that the pipe operator, we pronounce it as then. So we take the diamonds data set and then we select the columns price, carat, x, y, and z. And this is what we get. So this is one way to kind of start becoming familiar with the data set. One other thing that I didn't show is a tool called Glimpse. So also comes with the tidyverse, specifically with the dplyr package. It is a different view of the data set, and it's kind of useful because it scales up very well. So if your data set has, say, 100 columns, each of those columns is going to be listed one under the other one, so that then you can just scroll down and have an overview of the entire data set. And then you also get the type of column. So for example, carat is a double column, a numeric column. We know that price is an integer column, for example. There is like it's like all round price numbers. And then we have a few values, just whatever you can fit on the screen, depending on what size of screen you have at the time that you call that function. So that's a cool function to be aware of as a way to start gathering some very basic information about your data and start prompting your brain the questions that will drive your exploratory data analysis, which is the point. So let's start with this idea of trying to understand the most common and the most rare values in a data set. So last time we worked with two types of bar plots. One is like necessarily directly called a bar chart, and the other one is a histogram. Both of them represent data in bars, and then the toolbars are the ones that are going to be showing us the most common values. So it's very easy, using a histogram, for example, to see which are the most common values in the entire distribution of the variable. And on the other hand, shorter bars will tell us the less common values, and gaps in your data. When you see that your histogram is kind of broken, you may start having questions about why do I not have data in that specific range of values for this variable. So we're going to be seeing this in a moment, but those very basic aspects of a data set may prompt us some questions that are useful just in about every data science exploration that you do with any data set, pretty much. For example, which are those most common values and why? Which are the most rare values and why? And does that match your expectation, yes or no? Before you even explore your data, you may have some assumptions or some expectations about what that data set contains. So it's very interesting to try explicitly articulate those questions in your head or in writing, and then see if your exploration matches that expectations or not. Also, can you see any patterns, like groups of data that may have some meaning? And if you see those groupings, are they just random groupings, or do they have some meaning that you can derive from there? So those are questions that are very general, and you could apply them to just about any data set. But now let's have a quick look at some real data and see how that data can drive these couple of questions. So what we're going to be doing is, let's first take the dataset diamonds, and then let's filter just the values, just the rows where the column carat is less than 3. So carat was the weight, remember, and we're focusing on rows that are less than 3. So now we assign the result of that to a new data set called smaller, which contains just a subset of that data, and we plot it with the tool that we are using, ggplot. Remember, then we usually give it as the first argument the name of the data set, and then the mappings we can either give it to them in the ggplot call, or you can also give it in the geom call. In this case, we are choosing to do it in the ggplot call. So we're going to be using a geom histogram, which is the geometric representation that we choose for this specific plot. And this is what we get. We choose a bandwidth that is very narrow, just a 0.01 width, and because we have a huge data set here, and this is what we get. So the questions that may come to mind, so notice how, for example, we have bars that match the white grid lines underneath, and those white grid lines correspond to round numbers like 2, 1, 1.5, 1 1/4, that we don't have it, but it will be here. So notice how there seems to be more values or more diamonds with a weight that is exactly around either the big kind of the round numbers, or at like the nice fractions of those numbers, like half of something or a quarter of something, right? So this is one question that you may ask, like, why do you think we have more diamonds at whole carats and or at common fractions of carats, and then also why there may be more diamonds slightly to the right of each peak as opposed to the left. So because this ds-incubator series is more about, well, it's a mix, between the tools, but also about the questions that you may ask to your data. I would like to kind of stop now for a moment and try to see if anyone has any idea. As for, you don't have to be right or wrong. This is an exploration. We're just brainstorming, ideas. So if we make these observations, like we see that there are more diamonds at the round carats or fractions of carats that are like nice fractions, and we also observe that the distribution of the values around those peaks is kind of biased to the right. Any idea of why that might be a case here in the room? Go back to your three faces here. Or maybe what I should do is I leave the plot so that it prompts. So my questions are, let's see who we have here. Katarina, go ahead. Correct, yeah. Perfect, yeah, I agree, yeah. I agree with you. I mean, diamond, these are diamonds that are processed, and I'm guessing, I mean, I haven't read very deeply about this particular data set, but I'm guessing that they are for sale, right? So someone created these diamonds and they gave it a price and stuff. So yeah, I don't think they just come from nature. I mean, someone has had to kind of craft them in a way. Yeah, that's what I think. Oh yeah. Yeah. Okay, yeah, I take your. I think it's interesting the rounding one, but I think that wouldn't explain, for example, a bias towards the right. So you say, for example, if if I'm someone weighting the thing and I see putting the diamond on my scale and I see 0.8, I would okay 1, and if I see 1.1, then okay 1. But so I could get how I would get more peaks in the ones, but that doesn't explain why I see such a clear kind of tail on the right. Any other one? I think we can build on that. I think my guess is that there is some human choice here or human decision in influencing the numbers for sure. But I would love to see if there is any other idea that could also explain that bias to the right. Anyone ideas? I like that. That kind of explains the round numbers in a very kind of human bias way. May I throw one because also I would like to kind of move on. So I'm gonna also, the good ideas come from asking many ideas, right? So the more questions, if we spend 5 minutes with all these brains here, I'm sure we will come up with very good potential answers to that question. And I've been working with this for a few hours now, so I have some ideas too. I'm thinking that these are diamonds for sale. So if I'm the person that wants to sell diamonds, I think like people like round numbers. So someone may want to, okay, would you like one that is at 1 carat or 1.5 carat? But would you like one that is 1.23 carats? Maybe my clients, I know, like give me 1 or give me 2, give me 1.5 or 1.25. So I think that explains peaks, like around kind of beautiful fractions. But then the bias, I think, is because like as a client, if you tell me, hey, this is 1 carat, okay, good, show me, and you weight it, and it's like, like 0.98. Is that way you're trying to charge me for 1 carat, but you're giving me only, a little less? So my intuition is that clients will complain more if you are biased to the left, that if you're biased to the right. So that's, that was my own explanation. I see someone else with another idea. Go ahead. Oh. Some kind of mathematical law, you mean? Yeah. Yeah. So yeah, I think that the point is made is that in this case, and the book actually poses a bunch of questions but no answer, precisely because I mean, the answer will be specific for this data set, but it doesn't really matter because we don't care about this data set. We care about, the data set that we work with. But the book is teaching us to, use data or exploratory data analysis as a way to prompt questions and come up with answers that may be relevant for our specific use cases. Go ahead. I see a hand over there. CJ. Yeah. Okay, cool. Exciting that you are engaged in the questions that come to our brain when we start revealing some aspects of the data that are there but are hidden until we expose them. And great ways to expose them is like with good counts, with good histograms and things like that. Like this is like nothing like really earth-shattering, just a very basic tool. Like a histogram is like super basic, and still see how it can reveal a bunch of questions. Another aspect that we're not going to be covering in depth is the idea of patterns that are created by groups of data that they could be just at random, but at least you have to try make an effort to explain those patterns in your head. Like, are they really random? And if there is a pattern, then later we'll see tools to try extract that pattern and confirm if it is what you thought it was. Or not. Basically, that comes mostly with the relationship between two different variables. So one variable explains a lot of the values that you see in another variable. So questions that may come from observing patterns are like these ones here. Like, how do the observations within each cluster are similar to each other, and how they are different to observations in a different cluster. And why you also need to ask why the appearance of the cluster might be misleading. So in the case of, for example, perfect, thank you, thanks a lot. I probably need you to again say something at 25 past or so, because we are we're going to be kind of interacting more than in the typical meetup. So one aspect that I was thinking in terms of how a pattern could be misleading is this idea of the beam width that we explored the other day. So let's see where we are here. I think here, if I run all the chunks on top of this one, run this histogram. Okay, I see here. I can see with this specific beam width, I can see some patterns like the ones we were trying to explain, right? That there is like some peaks around the whole numbers and then around the fractions, the nice fractions of whole numbers. But if I went like 0.5, if I just change the beam width, I see a completely different pattern. I see that most of the diamonds are less than 1 carat, around like a little, what is it, like the half of a carat. So that pattern was there before, but wasn't all that obvious, and we have totally kind of lost this idea that there is a lot of we have lost the patterns that we saw with peaks around each of the nice fractions of a carat, right? So the idea of patterns being misleading or being hidden might have also has something to do sometimes with how you are exploring your data. If you're visualizing it, for example, in this case, with a beam width that is not the right beam width to explore the specific pattern. So that's why it is always recommended to explore a bunch of beam width. You go 1, you go 0.5, you go 0.01, like everything. So you start seeing alternative patterns and coming up with alternative questions so that you can then focus your attention in what seems like a promising pattern to explore. I see Anne, go ahead.
A quick question on that. Mom, so when I did histograms, it was like sometimes that R was telling me it's not the right bin width. Do you have any advice or do you have any suggestions to make, like how to find a proper bin width from the beginning onwards? Because I don't know, or is it really just exploring and trying out several things? And then also, why is R telling me this?
Yeah. Honestly, I am not familiar with the message that you mentioned. Maybe if you can unpack that a little more, just because I'm very curious. What I read in this book and in general is that it's very exploratory. Like the right being width, it depends on what are you asking. Actually, it depends on your question, right? Maybe if you are interested in like precisely explaining how people behave when they cut diamonds, maybe being with 0.01 is a good one because it reveals that pattern. But maybe your research question has nothing to do with that, and then that being with is not useful to you. It's more like, okay, from all the diamonds, which are the ones that people buy the most, and maybe that 0.5 being with is more useful because it reveals a peak around the half carat. So I think it's totally dependent on your question. So please explain a little more about that idea of R telling you. Do you remember which function it was that told you that?
Yeah, I will. Definitely, I can just it's the normal ggplot histogram function, and then with just the same code that you have right now there. But I will what I can do. I will just after the meeting have a look where I found it and make a screenshot so that you can see it.
Perfect. There are some messages that I think we're gonna have time to show that relate to values that are being dropped because they are missing. And I remember seeing those messages, but honestly I don't remember seeing that. CJ has his hand up, so maybe he does remember the message or something else. CJ, please go ahead.
No, I was going to just mention that histograms are problematic for continuous variables, and there are alternatives to plotting distributions of continuous variables. So the histogram works well with discrete variables that have a fixed bounded range of possible values, and then also determining what kind of bin you want for your histogram is a little more rational with a discrete value. But with continuous, you have to kind of play with this because you have to capture so many of them, but it's really a bit arbitrary. But there are other plotting things like a density distribution. I think there's even ggplot has one like a geom density or something like this plot, which is a bit more realistic for visualizing the distribution of a continuous variable like this current.
Mm-hmm. Yeah, we covered a little bit on touched a little bit on that last time. Only cover the difference between the geom bar and the geom histogram, which the geom bar, once you already have something that is already discrete, you would put the bars in the right places, and the geom histogram would discretize a continuous variable based on the bin width that you choose. Or you could, we also did it manually. First we, with dplyr, we used cut width from the ggplot2 package to cut a continuous variable in discrete intervals, and then transform a continuous variable into a discrete one, and then use geom bar to plot those things. I think that the most important point that CJ highlights is that so there is different tools at your disposal. The more tools that the better questions, the easier you will find you will have it over time when you are trying to refine your questions. So far in this first kind of, I would say, like introduction to exploratory data analysis, we are using like very kind of coarse tools, good enough to kind of get a good understanding, but surely, as EJ highlights, you probably need more tools once you get kind of narrower into specific aspects of your data. Any other thing you would like to share, CJ, before we're not going to be covering everything anyway, so I'm happy to use the time for some more comments and see how far we can go. Can I go back?
I mean, you could probably try a geom density just to see what it looks like.
Right. See.
Sorry, I just want to say that it's 10:28 yet. It's 28 past. I didn't want to.
Thank you. Lovely. Let's see what we get. So in this case, actually, I shouldn't have removed this one, so we can compare. One cool thing we could do is to overlay the two. So let's do that. If it is still there, I would love to be able to compare. And maybe the density, I would do something like color. Color. Let's say blue. For some reason, it looks like it's being kind of pushed. Because one is the count, and the other one may have just the scale of the variables themselves. Or I'm not sure. I mean, I need to explore more. But I think it's interesting. It's kind of the profile of the histogram as opposed to the bars. So somehow, I could imagine like a line being drawn, up and down along this thingies. Maybe if I change the beam width, I could make it even more similar.
I mean, your y-axis can be on a totally different scale, so you're never going to see them really next to each other unless you modify the scale.
Yeah. But good. I mean, I think the most important point that you bring is the one of different tools may reveal different aspects of your data. You can't do everything with just a histogram. For now, I'm gonna kind of feel happy with showing what we have. Let's see what else. Okay, so let's try. So we did talk about the idea of patterns. Maybe yes, we are. This is a pretty important topic. The idea of outliers. And how we can zoom in. So I'm gonna leave this for the next meetup. So next time we're gonna be talking about outliers and transforming them when we are sure that they are bad data, transforming them into missing values and then into logical values in a binary variable, so we can plot them and visualize them. So this is now then the end of as far as we could get. Thanks a lot for being chatty today and sharing your ideas. See you next time.
Bye, everyone.
Ciao, ciao.